Welcome to Git Command Basics. This presentation will cover the fundamental aspects of version control using Git. Git is a powerful tool that helps you track changes, collaborate effectively, and manage different versions of your projects. Here we are showing the Git icon. Git helps you to track changes. It monitors file modifications and maintains history, enabling you to revert to previous versions if needed. It allows multiple people to work together seamlessly on projects, resolving conflicts and ensuring everyone has the latest updates. Git enables you to create isolated environments for new features or experiments, keeping your main project stable. Before you can start using Git, you need to install it on your system. Here are the steps to install Git based on your operating system. For Linux, open your terminal and run the command sudo apt install git or sudo yum install git, depending on your distribution. For macOS, if you have Homebrew installed, simply run the command brew install git. For Windows, download the installer from the official Git website, which is gitscm.com, and follow the installation instructions. After installing Git, it's important to set up your user information. Open your terminal or Git bash and use the following commands. To set your username, type git config, global user.name followed by your name in quotes. For example, git config, global user.name your name. Similarly, set your email address with git config, global user.email followed by your email in quotes. For example, git config, global user.email, your .email at example.com. You can verify your configuration by using the command git config list. Optionally, you can set your preferred text editor for Git using the command git config global core.editor followed by the editor name. For example, git config global core.editor vim. A Git repository is essentially a storage space for your project. It houses all your project's files and meticulously records the history of each file's revisions. There are two main types of Git repositories. The first one is local repository, which is located on your computer and used for day-to-day development. You can either create a new local repository or initialize one in an existing directory. The second one is remote repository, which is hosted on a server like GitHub, GitLab, or Bitbucket, and facilitates collaboration among team members. You can clone an existing remote repository to your local machine. To initialize a new Git repository in your project directory, use the command git init. This command creates a new .git subdirectory in your current working directory, which contains all of your necessary repository metadata. To clone a remote repository, use the command git clone followed by the repository's URL. For example, git clone https://github.com/username/repository.git. You can check the current status of your repository using the command git status. This command shows you which files have been modified, staged, or are untracked. The Git workflow consists of several stages. First stage is the working directory. This is where you make changes to your files. Second stage is the staging area. This is where you prepare your changes for commit. Third stage is the local repository. This is where you store committed changes on your local machine. And fourth stage is the remote repository. This is where you share changes with others. To add files to the staging area, use the command git add followed by the file name. For example, git add filename.txt. To add all files in the current directory, use the command git add followed by a dot. For example, git add. To commit the staged changes, use the command git commit followed by a meaningful message describing the changes. For example, git commit m, add new feature. To push your local commits to a remote repository, use the command git push origin main. To pull changes from a remote repository and merge them into your local branch, use the command git pull origin main. To view the configured remote repositories, use the command git remote v. The git status command is used to display the current state of your working directory and staging area. It shows you which files are modified, staged, or untracked. The command is Git Status. The Git Diff command is used to show the changes between your working directory, staging area, and commits. It helps you review modifications before committing. To compare the working directory with the staging area, use the command Git Diff. It will output the differences between the current state of the files and the changes you've staged. In the output, lines marked with a minus sign are removed and lines marked with a plus sign are added. Branches in Git allow you to isolate development efforts, experiment with new features, or fix bugs without affecting the main codebase. They provide a way to work on different versions of your project simultaneously. Here we have a diagram showing different branches. Main branch is representing the production-ready code. Feature branch is representing development of new features. Bug fix branch is representing the branch dedicated for bug fixes. To list all the branches in your repository, use the command Git Branch. The current branch is marked with an asterisk. To create a new branch, use the command Git Branch followed by the branch name. For example, Git Branch Feature Login. To switch to a branch, use the command Git Checkout followed by the branch name. For example, Git Checkout Feature Login. You can create a new branch and switch to it in one command using Git Checkout B followed by the new branch name. For example, Git Checkout B New Feature. Merging in Git is the process of integrating changes from one branch into another. It combines the work done in separate branches, allowing you to bring new features or bug fixes into your main codebase. There are two main types of merges. First one is fast-forward merge. This occurs when the target branch has no new commits since the source branch was created. Git simply moves the target branch pointer to the latest commit of the source branch. Second one is three-way merge. This happens when both branches have diverged. Git identifies the common ancestor, applies the changes from both branches, and creates a new merge commit. To merge a branch into the current branch, first switch to the target branch using the command Git Checkout followed by the branch name. For example, Git Checkout Main. Then, use the command Git Merge followed by the name of the branch you want to merge. For example, Git Merge Feature Login. If Git encounters conflicts during a merge, it will pause the process and ask you to resolve the conflicts manually. These conflicts typically occur when the same lines of code have been changed in both branches. Remote repositories enable collaboration with others and allow you to back up your work on a server. They serve as a central hub for sharing changes and coordinating development efforts. Here are the main remote operations. First is push. This operation uploads local commits to a remote repository, making your changes available to others. Second is pull. This operation downloads changes from the remote repository and merges them into your local branch, ensuring you have the latest updates. Third is fetch. This operation downloads changes from the remote repository without merging them into your local branch. This allows you to review the changes before deciding whether to merge them. To list the configured remote repositories, use the command Git Remote V. This command displays the name and URL of each remote repository. To add a new remote repository, use the command Git Remote Add followed by the remote name and URL. For example, Git Remote Add origin https://github.com/username/repo.git. To push your local changes to a remote repository, use the command Git Push U origin main. To pull changes from a remote repository, use the command Git Pull origin main. Gitlog is a powerful tool that allows you to view the commit history of your repository. It shows who made changes when they were made and the associated commit messages. It's essential for understanding the evolution of your project. You can filter logs by author, date range, or file path. You can customize the output format to display the log in a concise or detailed manner. You can limit the number of commits shown to focus on specific periods. To view the basic log, use the command Git log. This command displays the commit history in chronological order. For a more compact one-line format, use the command git log, one line. To visualize the branching structure, use the command git log, graph, one line. To see the changes introduced in each commit, use the command git log p. Here are some of the best practices when working with Git. First is commit often. Make small, focused commits with clear messages. Second is branch strategy. Use feature branches for new development to keep your main branch stable. Third is pull before push. Always pull the latest changes from the remote repository before pushing your local commits to avoid conflicts. Fourth is use .git ignore. Exclude build artifacts, dependencies, and other unnecessary files from version control to keep your repository clean. Fifth is review changes. Use Git Diff and Git Status before committing to ensure you are committing the correct changes. Sixth is descriptive messages. Write meaningful commit messages that clearly describe the purpose of each commit. Here are some of the resources where you can learn about Git. Git documentation is available at gitscm.com/doc. Interactive learning is available at learngitbranching.js.org. Pro Git book is available at gitscm.com/book. Git cheat sheet is available at github.github.com/trainingkit. Thank you for watching this video. If you have any question, please ask. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.